Hello and welcome. In the previous video, we discussed about sets and subsets. We discussed the definition for sets and subsets. We'll continue our discussion on subsets in this video as well. Subsets. So we know that uh, if we consider two sets A and B, if all the elements, all the elements of set B belongs to set A, then set B is a subset of A. Subset of A. Notationally, we write B subset of A. Example will take A is 1, 2 and 3, B as 1. So B is subset of A because element 1 is present in A. If you take example C is called 5 comma 6, C is not a subset of A because both 5 and 6 does not belong to A. Even one element does not belong to the original element. The other set is cannot be called as subset. So in other words, what we can say is a subset is actually is a part of the original set. It's a part of the original set. Even though we write the subset in a different name, it is actually a part of the original set. So we can actually, so the subset means it is generated out of the original set. So it drives us to inquire more about the subsets, like if the subset is a part of the set, can we generate number of subsets out of the original set? If it is possible to generate subsets from the original set, how many such subsets, how many subsets we can generate? How many subsets can be generated with the original set, with the set? So this is our next question, and actually this is the concept for this video. Okay. So now let us take one simple example. I'll start with two elements. Let us take A is equal to 5 and 6. So there are two elements here. The number of elements in set A is 2. So I'll start generating subsets, taking one element at a time, one element at a time. So I can A1, I'll write it as 5. So is A1 subset of A? Yes, it is, because 5 belongs to A. Similarly, I can generate another subset with another element 6. So I can generate two subsets taking one element at a time. So here we got 2. Now let us take two element at a time. Taking two element at a time, I can write A3 as 5 comma 6. So is A3 a subset of A? Yes, it is, because both 5 and 6 belongs to A. In fact, A3 is nothing but A itself. So this tells us this tells us a subset can be set itself. So another one more note we can take it here is every every set every set is a subset to itself. Every set is a subset to itself. And one more note we have to take is every empty set is also a subset of a set. So for every empty set we have to take it as a subset. Every empty set every empty set is a subset, or empty set is a subset of every set, and write like that. Empty set is a subset of every set. So this tells us for n is equal to 2, we could actually generate four subsets. Let us take one more example to understand it better. I'll take now three elements. 1, 2, and 3. So let us start generating subsets for A, taking one element at a time. Take one element at a time. A1 equals 1, A2 equals 1, sorry, A2 equals 2, A3 equals 1. So when you take one element at a time, the number of subsets we are getting is 3. How we are getting this 3? Getting it as 3. We can use the concept of combination. Like we have 3 elements in A, and the combination we are taking is one element at a time. So 3 combination 1. So 3C1 is actually 3P1 by 1 factorial. 3P1 is 3 by 1, which is 3. Similarly, when you take two element at a time, the number of different combinations are A4 is equal to 1 comma 2, A5 is 1 comma 3, and A6 is 2 comma 3, and we don't get any other options, I guess. So it actually, the number of subsets when you are taking two elements at a time is also 3. Let's see with this calculation. 3 elements combination 2. So out of 3 elements we are taking 2 at a time. So it is 3C2, 3P2 by 2 factorial. 3P2 is 3 into 2. 2 factorial is 2. So 2 and 2 can cancel. So it is 3 again. Only if I take 3 elements at a time, we get A7 is equal to 1, 2, 3. So this is A itself. So I already told you that every set is also a subset to itself. So when you take three elements at a time, one element, so we can take calculation 3C3. 3 elements combination is 3. 3C3 is always 1. Finally, we should not forget to take the empty relation. So totally we have 8 subsets. So when n is equal to 3, we are getting 8 subsets. Finally, we'll take one more example. Let us take 4. 1, 2, 3, and 4. So I'll take one element at a time. A1 is 1, A2 is 2, A3 is 3, A4 is 4. So total number of elements is 4. Calculation is 4 combination 1. 4 elements, we are taking one at a time, which is 4P1 by 1 factorial. 4 by 1 is 4. Now let us take two element at a time. A5 is equal to 1 comma 2. A6 is equal to 1 comma 3. I'm combining 1 with all the other elements. A7 is 1 comma 4. A8, I'll start combining 2 with other elements except 1, because 2 is already paired with 1 already. 2 comma 3, 2 comma 4. Finally A10, we have to combine with 3 and 4. 3 comma 4. So totally we have 6 here. 1, 2, 3, 4, 5, and 6. Let's verify this through the formula. 4C2 is 4P2 by 2 factorial. 4P2 is 4 into 3 divided by 2, 2 and 2. So this is 6. Right. So let us take 3 elements at a time. When you take 3 elements at a time, we'll get A11. 11 is equal to, I'll combine 1, 2, 3. A12 as 1, 2, and 4. A13 as 1, 3, 4. A14 as 2, 3 and 4. So there are totally 4. Let us verify this. 4 elements combination 3, 4C3. 4C3 is 4P3 by 3 factorial. 4P3 is 4 into 3 into 2 divided by 3 into 2. 3 and 3, 2 and 2 will cancel, so I'll get 4. When you take 4 elements at a time, so this is actually the set itself. A15 is equal to 1, 2, 3, 4. There is 1. So we know that 4C4 NCN is 1. Finally, we have to take the empty relation. So there are, for n is equal to 4, there are 16 subsets. So let us generalize this. For n is equal to 1, the number of subsets is 1 actually. When you take 2, we saw an example, it is 4. When it is 3, it is 8. When it is 4, it is 16. When it is 5, we can actually compute it. 5, when you take one element at a time, it is 5C1. 5C1 is 5. When you take 2 element at a time, it is 5C2. 5C2 is 5P2 by 2 factorial, which is 5 into 4 by 2, which is 10. 2, 1, 2, 2, 5 into 2 is 10. Next, 3 at a time, 5C3. 5C3 is 5P3 by 3 factorial, 5 into 4 into 3 divided by 3 into 2, again it is 10. We get 5C4. 4 elements at a time, 5C4, which is 5P4 by 4 factorial, which is equal to 5 into 4 into 3 into 2 divided by 4 factorial. We can cancel this 4 factorial this way, thus we will get 5. 5C5 is 1, and we have empty relation, which is 1. Empty relation is equal to 1. So totally we have 5 plus 10, 15, 15 plus 5, 25, 25 plus 5 is 30, 31, 32. So for 5 it is 32. So this I can actually write 2 power 1, 2 power 2, this is 2 power 3, 2 power 4, this is 2 power 5. So generally for n it is 2 power n. So what does it mean? It means if a set has p elements, then the number of subsets is 2 power p. Very, very important factor. Let us conclude this video with one more concept called as proper subset. If I have a equals 1 and 2, the subsets are a1 equals 1, a2 equals 2, a3 equals 1 comma 2, and a4 equals empty. So here we can note, when we generate the subsets out of the original set, one of the sets, one of the subsets will be equal to the set itself. So here A3 is A itself. So this, if a subset is equal to the original set itself, this is not a proper subset. This is not a proper subset. All the other elements are proper subsets. All the other are proper subsets. So if there are p elements in a set, we can generate 2 power p subsets. Out of 2 power p, one is not a proper subset. So the number of proper subset is 2 power p, 2 power p minus 1. Let us continue our discussion in the next video. Thank you.